moving up, down, and we talked about flipping vertically and horizontally. But what about stretching things or shrinking things? That's what we want to talk about today. If you were to see this, a function turned into a times f of x, notice how the a sits on the outside. And if it sits on the outside, it impacts it vertically or horizontally? Vertically. Stop throwing your pencil. Yeah. Okay. So, if you see an a on the outside, if the absolute value of a is greater than 1, so for example, suppose that there's a 3 sitting on the outside, that's going to vertically stretch it by a factor of 3.
This part of the description.
Suppose that you have a number that's smaller than 1 on the outside. Suppose that the absolute value of a is less than 1. So suppose you had like a 1/4 on the outside. You guys can make it bigger or smaller.
Smaller.
Smaller. It's going to shrink it. So when it's on the outside, it does exactly what we think. If it's a number that's bigger than 1, it makes it bigger. If it's a number smaller than 1, it's going to make it smaller. Simple as that. If you see a number on the inside of the function multiplying x, that's going to impact it horizontally because, again, it's on the inside. Does that shift to the right 3 or left 3?
Right 3.
Everybody agree that's kind of opposite what you think? The same thing happens for these. It's opposite of what you think. So suppose that you have the absolute value of a is greater than 1. You might think, well, it's going to stretch it horizontally. It does the opposite. It shrinks it horizontally. And the factor is the reciprocal. So suppose I had like the square root of 4x. People might be like, oh, it's going to stretch horizontally by a factor of 4. It's going to shrink to 1/4 the size. It's going to shrink to 1/4 the size.
After factor in the first description, is that of
A.
I mean.
Of A. A is your multiplier.
A.
Okay? So suppose that the absolute value of A is less than 1. It's going to stretch. By factor of 1/8. Okay? By the reciprocal, as you said. So for example, suppose I had the square root of 1/5 x. People saw the 1/5 on the inside. It's not going to make it smaller by 1/5, but it's going to stretch it by a factor of 5. 5 is going to make it bigger, right? 1/5 will make it smaller. So it's going to be by the reciprocal of what you see. Okay? All right. So that's the general idea, and that leads us to all the transformations combined. And I want you to understand that I'm trying to set you up for success that we're going to encounter in second semester. Because second semester, I need you guys to be able to do this. I need you to be able to graph y is equal to -3 cosecant of 4x minus pi over 2 plus 1. Does that look a little bit more challenging than the ones we've been doing?
Yeah.
Yeah, that actually ends up being the highest scoring test for you guys during the course of the year. Right now, you don't know how to do it. But in order to get you to do this, I need you to understand that the +1 is going to move it up 1 unit. I need you to understand that the negative on the outside is going to create vertical flip. I need you to understand the 3 on the outside is going to create a stretch. Those are all things I need you to have the idea on. As far as cosecant, what does that graph look like? I can teach you that later on, but you have to understand the general transformations. And that's what we're going to piece together right now and try to lock in. And by the way, this generally has gone very, very well in the past. And since you guys are an extremely intelligent group, it should go well for you also. So this plus D on the outside there, how does that impact the function overall? We review.
It either brings it higher or lower.
Yep, up or down. D units, right? That's the easy one. You see that thing added on the end, just moves it up or down. Things are easy when it's on the outside. What does this A on the outside do?
Flips it, right? If it's positive,
If A is positive, the graph goes up. If A is negative, the graph goes down. So it does have a component in terms of it flips. But I heard somebody say stretch. Is that Carter?
yeah.
Yes, this does create a stretch or a shrink up or down. Okay? This also creates a stretch or shrink up or down. Man, I've spelled stretch wrong 4 times today. Okay, so that number in front is going to create a stretch or a shrink vertically, and it's going to flip it, as well. This number on the inside there, okay, if B is positive, it heads off to the right. If B is negative, it heads, If B is negative, it heads off to the left. And we talked about that also creates a horizontal stretch or shrink. And then the last thing I want to talk about in this is I'll give the example. Suppose I had the square root of 4x plus 8. Everybody sees the 4, they're like, okay, that's going to create a horizontal shrink. You're correct. But if I wanted to know the shift here, I would have 4 times x plus 2. Is that going to be 2 units to the right or 2 units to the left?
To the left.
To the left. And does everybody see how I came up with that by factoring out 4?
Yeah.
I actually used to do that a different way. I used to not factor it out. I would just say 4x plus 8 is equal to 0, and I would solve. I would get 4x is equal to negative 8. I divide by 4, I get x is negative 2. Since I come up with a negative 2, that means I move to the left 2. See what I'm saying?
Yeah.
See how this negative 2 corresponds with the x plus 2? 2 to the left. And so I always just say this is bx minus c is equal to 0. Just solve, and that's your horizontal shift. So whenever I see something inside, I just always solve it equal to 0, and that always tells me my horizontal shift every time. Okay? So let's try the example. This is what you're going to be wanting to do on your homework today. You guys have already done a few of these pieces. But you're going to draw this little shape here. There's just 4 coordinates, and these are the 4 coordinates that you're going to put down. So put that on your notes. We just want to get through these examples, and then you guys can have some time to work here. We will not do a test on a Monday. We'll do a test on Tuesday, unless you want a Monday test. We got your dots down? Okay, so talk to the person next to you. What do you think this 2 is going to do to the function? What do you think the 2 is going to do to the function? Don't actually write anything down. Just tell the person next to you what do you think it's going to do. Go. Take 30 seconds. What's it going to do? Go.
stretch? If it was negative, would it shrink it?
A negative would flip it.
Okay, is the 2 on the outside or inside?
Outside.
So is it going to impact it vertically or horizontally? Vertically. So this is going to be a vertical stretch by a factor of 2. So what we're going to do is we're going to produce the new coordinates after the vertical stretch by a factor of 2. If it's going to impact it vertically, is that going to change the x values or the y values? The y values are vertical, right? So this will not change anything about the x values. So the x values will stay the same. -1, 0, 1, and 4. Those are exactly like they are. But all of the y values I'll multiply by 2. And I get 2, 6, 6, and 2. And so I'm going to plot these points. And if I've done it correctly, I should end up with what you guys said, is a new shape that's stretched by a factor of 2. Look at this shape. See how it's 2 units tall? This one is 4 units tall, isn't it? It's stretched to be double the height. Look at our next one. Now I've got this 0.5 on the inside. Does this 0.5 impact it horizontally or vertically? Horizontally. And when it's on the inside, it's opposite of what I think. So this number is 1/2. So is 1/2 going to make it smaller or is it going to make it bigger?
Bigger.
Makes it bigger. It's opposite of what you think. It's going to make it bigger by a factor of 2. It's the reciprocal of what you see. So although you see 1/2, don't multiply the inside by a half. You multiply the inside by a 2. So if it impacts it horizontally, is that going to change the x values or the y values? X values. So I'm going to take all these x values and multiply them by 2. Not 1/2. I do the opposite, the reciprocal. So I get -2. I get 0. I get 2. And I get 8. What does the +1 do? Vertical shift up 1?
Yeah.
Okay, so is that going to change the x or the y?
Y.
The y. So what do you think I do to the y?
Add water.
I'm going to add 1 to all the y's. So when I plot this, I should see that horizontal stretch and a small shift vertically. And that definitely looks like it's stretched horizontally. Okay? We got 2 more left. We got 3 transformations here. Talk to the person next to you about what all 3 of those transformations will do. Go.
Move it
Talk.
down 3.
40 seconds.
And move it to the right 1. So we got 0.
What is the negative?
-2.
The negative's on the outside,
-5.
vertical flip. Negative on
And
the
then
inside,
we move it
horizontal
down.
flip.
-2.
I gotta go for this. Okay.
Okay, so we've got this, and we always start in the order of operation. So if you were to plug something in for x, the first thing you would do is you would subtract 1. What does an x minus 1 do?
Right.
Shifts it to the right 1. So careful here, okay? If I'm shifting it to the right 1, what do you think I do to all the x values? I add 1. Does everybody agree? It looks like you would subtract 1, but remember, you do the opposite, okay? If this is right 1, then we got to add 1 to all of our x's. So as I add 1 to the x's, I get a 0, I get a 1, I get a 2, and I get a 5. Now, if I plug something in for x, I would subtract 1. The next thing I do is I'd apply the negative. The negative is on the outside, so it's going to impact it vertically. So that could change the x or y values. Why? Notice like here, the height is 3. A vertical flip would put it down at -3. So what do you think we do to all the y values? We flip them, right? We flip them from +1 to -1, +3 to -3. But then, after that, what should we do to each y value? Subtract the 3 as well. Okay? So I'm going to switch the y to -1 and subtract 3 to get -4. Switch the 3 to -3, subtract 3 to get -6. And the new shape that I get should be upside down. So we have that in our mind to see if that is actually accomplished. Does it appear to be flipped upside down? It sure does. And there's a slight shift, over 1 and down 3. Okay, our last example for the day. I'm going to list out x and y. I start on the inside. What will the negative x do? The negative's on the inside. What's that? Horizontal flip. So that could change the x or the y. So what do you think I do to all the x's? Flip them. So I've got a 1, a 0, a -1, and a -4. To the y values, am I going to add 2 and then multiply by 2? Or am I going to multiply by 2 and then add 2? Multiply, then add. You got to do it in the order of operations, okay? So I multiply the y value by 2 and add 2. So 2 times 1 is 2, plus 2 is 4. 3 times 2 is 6, plus 2 is 8. And again, we get an 8 and a 4 as those values repeat themselves. So this thing should be flipped horizontally after I graph it. And it should be stretched a little bit, kind of like the first one, and it sure is. And it's shifted up too. Okay? Take out your homework so we can talk about what you're trying to focus on here, okay? This assignment says transformations of functions. And on the front page, make sure everybody's here so you can understand the directions. I want this to be pretty quick for you, okay? The first one is f of x minus 3. So what's that going to do to the function? Down 3, right? So you just write down 3. Look at letter B. It says f of x minus 3. That's going to move it to the... So you just write right 3. That's all I have to do, okay? A couple things to make note of there, okay, that I want everybody to understand, is that if you get... So a couple people missed this last hour. If you get a -2 times f of x, that's a vertical stretch, but it's also a vertical flip. Does everybody see that there's 2 components here? So, you know, you got to write both a vertical stretch by factor 2 and a vertical flip, okay? All right, I'll flip it over to the next page. So you also want to work through the second page. And for section 2, that's where you want to generate a new set of coordinates based off the function below. So what I'm going to do is I'm going to give you some coordinates for that function below. So write those off to the side. We just want 4 coordinates. Anybody want to guess what our first coordinate should be?
2, 1.
We're going to do 0, 1. Do you agree that that graph kind of starts at 0, 1? And then it goes up to 1, 2. And then you got 4, -1. And you got 6, 0. Those are your 4 coordinates that you're going to be messing around with for that one, okay? And then finally, if you look at the problem on the bottom, that's simply a matching exercise. Okay, there's 5 graphs there. Well, the one in the middle that looks like this, so the middle one just says f of x. And then there's 4 other graphs. You got to just pair them up with which one you think is right. Okay? So, don't have a lot of time right now. I will say that your assignment tomorrow, we get to it pretty quick. There's not a lot of notes to go through. Question? You do that.